This video is part of a series of short videos that each highlight a different strategy that can be used when verifying trig identities and an example of how it is used. The strategy highlighted in this video is multiplying out a factored expression. A factored expression, remember, is two things that are multiplied together, and usually that product is expressed using parentheses. Therefore, you'll know you want to multiply that expression out when the left side of your identity has parentheses to start with. So here's an example. Your directions for every verifying a trig identity problem will say, verify the identity by showing that the left side is equal to the right side. We know that we want to use our strategy of multiplying out a factored expression for this example because when I look at the left side, I see parentheses. On your screen, you can see my work for multiplying out the factored expression. Basically what I'm doing here is foiling. I'm multiplying secant times secant times -1, 1 times secant, and then 1 times -1. After multiplying these terms out, I see that I have a minus secant and a plus secant, which cancel out, leaving me with, in my second line, secant squared minus 1. A little hint before we move on. In that problem, when you saw secant plus 1 and secant minus 1, that should have reminded you of the difference of two squares multiplying shortcut. Every time you're multiplying two parentheses together and the two terms are the same but the signs are different in the middle, those middle terms are always going to cancel out when you multiply. So your answer is really just going to be the first thing, like the a squared, minus the second thing, the b squared. You don't have to worry about the terms in the middle. Now, at this point, we do still have to figure out how to turn secant squared theta minus 1 into tangent squared theta. And to do this, we need to use a strategy highlighted in another video, which is noticing that secant squared theta minus 1 should remind us of one of the Pythagorean identities. Now, if you check your list of Pythagorean identities, you'll see that secant squared theta minus 1 doesn't show up exactly on your list. But there is an identity that has both secant squared and 1 in it. That identity is tangent squared theta plus 1 equals secant squared theta. So I want secant squared theta minus 1. So to have the 1 with a secant squared theta, I need to subtract it on each side, which gives me tangent squared theta equals secant squared theta minus 1. This allows me to see that secant squared theta minus 1 is equal to tangent squared theta, so I can replace that in my work. So from secant squared theta minus 1, I made a little arrow and wrote that I was using a Pythagorean identity and switched that out for tangent squared theta, which verifies my identity. The last thing I just want to remind you about with this strategy is that although you do want to check that side work of making sure you're making a valid Pythagorean identity substitution, the side work that I have between the two green arrows is not required in your problem. All you need to do is show me, oh, I'm using a Pythagorean identity to get from secant squared minus 1 to tangent squared theta. So remember, when you see parentheses, multiply them out. Always keep this strategy in mind as you are trying to verify identities.